Okay, very warm welcome to all of you. Delighted to see so many people have come to a series of seminars which I think are extremely significant for the world we're in. This room was actually apparently an operating theatre before. So it's good to be talking about ethics of science in it. I'm Ian Golden, I'm the director of the Oxford Martin School, and what we are seeking to do is bring people together who are at the cutting edge of research in different disciplines to try and have interdisciplinary conversations which will advance the frontier and help us deal with some of the biggest challenges in the world. So this seminar series is designed to think about ethical issues across 6 of the different topics that we are dealing with in the school. And today is an extremely good kickoff with Professor Myles Allen, who leads our group on resource stewardship, and Professor Julian Savulescu, who is the director of the Oxford Martin Institute for the Ethics of Science. Julian also has been instrumental in motivating for this series, and I do want to thank you to him for all the work you put into that, and also to Alison and Clara, who helped to make it happen. So the series is going to cover a range of topics. Today, climate. Next week, on the 8th of February, we'll have Dapo Akende, who leads one of the co-directors of our group on ethics, law and armed conflict, and also the new program we're having on the rights of future generations, together with Alexander Livinghouse of the Oxford Institute of Ethics, Law and Armed Conflict. The following week, on the 15th of February, Paul Klinneman will talk about infectious diseases and the moral maze of pandemic control. The following week, on the 22nd of February, Jane Langdale and Miam Dolan, who are the co-directors of our Plants for the 21st Century group, will talk about the ethics of plant sciences, GMOs, and all of that. And on the 1st of March, Professor Steve Rayner, who's here, of the Oxford Geoengineering program, also involved in the Resource Stewardship program, in the Future of Cities programs, and many other programs in the Oxford Martin School, will talk about geoengineering and the ethics of that. And the final one on the 8th of March, Dr. Sonia Trigueros, who is the co-director of our program on nanotechnology, will talk about nanomedicine and some of the issues that are emerging from nano. So it's really a fascinating series of lectures, and I'm actually delighted to kick it off on a high point. Myles, over to you, and Julian, you're going to introduce Myles.
Thank you. Thanks, Ian. So how this will work is the speaker will speak about the science and their reflections on the ethics for about 40 minutes. I may make a few remarks for about 10 minutes, but then it will be open discussion, and today we have a couple of world-famous philosophers here, so I hope that they will be active in the discussion as well. Bennett Foddy will, my Deputy Director for the Institute for Science and Ethics, chair some of these sessions. But it's a great pleasure to kick it off with somebody as appropriate as Professor Myles Allen. As Ian said, he's the co-director of the Oxford Martin program on resource stewardship, for which I'm a member, and a professor of geosystem science. He's also the head of the Climate Dynamics Group in the University's Department of Physics. His research focuses on how human and natural influences on climate contribute to observed climate change and risks of extreme weather in quantifying their implications for long-range climate forecasts. He served on the Intergovernment Panel on Climate Change as lead author on detection of climate change and attribution of causes for the 3rd assessment in 2001, and as review editor on the Global Climate Projections for the 4th assessment in 2007. Myles proposed the use of probabilistic event attribution to quantify the contribution of human and other external influences on climate, specific individual weather events, and leads the Climate Prediction Net project, using distributed computing to run the world's largest ensemble climate modelling experiments. We are aiming that these are non-technical and open to a wide audience, so I'm sure Myles will put this in plain language for us all, and it's a great pleasure to welcome you.
Thank you very much, Julian. Well, that's I do appreciate the introduction, particularly Julian emphasising that I would talk about the science and other people would talk about the ethics, because I'm not an ethicist here. In fact, that was kind of my opening slide, really. I'm a physicist by background, so you may think, if standing in a humanities faculty, why am I here talking to you about resource stewardship? And I'll explain, but I'll emphasise the only thing I would disagree with about Julian's introduction was his suggestion that everybody keeps quiet while I'm talking, and then Julian will talk for a bit. I appreciate this is a diverse audience, and so I really don't want anybody to think, oh well, I'll just take his word for it if I say something which sounds like gibberish. So please intervene. If it gets out of hand, I may say, look, okay, let's just move on, and forgive me for that. But I think it'll be just generally, I think it'll work better for this kind of breadth of audience if people feel free to stick their hands up if I say something that sounds incomprehensible. If I say something you just flatly disagree with, then perhaps just wait, okay? But if I say something you don't understand, then please explain. So basically the background to this, and why am I involved in this resource stewardship program with the Oxford Martin School, is that I've been working as a physicist on climate change for many years, and we keep publishing papers saying different aspects, explaining different aspects of the climate problem, and nothing keeps happening. There's this sort of feeling that you can lead a horse to water, but you can't make them drink. And the real challenges in the climate problem are increasingly on the human side, the ethical dilemmas raised by the whole climate question, rather than the scientific problem of is the climate changing and what might that imply. I'm not suggesting at all, straight away, and I know there's some members of the physics department here, that it's all done on the science side. I think there's obviously plenty we still need to research in understanding climate change and understanding what it means for people, but it's for me, some of the really most interesting questions arise from where the sort of science and ethics overlap. So that's why the background to my interest in the Oxford Martin Programme on Resource Stewardship, which is a much broader programme looking at the challenge of resource stewardship across a large range of areas. The kind of questions that we really focus on in this programme, I'm just going to take 5 minutes to tell you a little bit about the On Pause programme. It's the interplay between technical information, illustrated here, for example, by the very detailed information that's provided on African climate, and actual decision makers. So the question which arises, which this sort of programme is trying to address, is how does we can improve the technical information we provide, we can improve seasonal and climate forecasts for Africa, for example, as hard as we can, but when we look at what people do, and Steve in particular has done some research on how people react to this kind of information, and you find that improving the quality, in inverted commas, of the information provided isn't always essential, or may not even make any difference to how effectively that information gets used. And this is the research Steve did was looking at the impact of relatively short-term forecasts. But I think the same analogy applies to the climate issue. We're beavering away trying to improve the reliability and precision of our forecasts of climate for 2050 to 2100. And yet I ask myself whether that's really the nub of the issue. Is it the fact that people don't know what's going to happen, the real obstacle to actually doing anything about it, climate change? And so this lecture is about thinking about what the real obstacles are, and actually sort of some of the ethical dilemmas that come up in discussing the climate issue. So most of this lecture will be about climate, but before I get on to that, I just wanted to just tell you what the different work streams in the Oxford Martin Programme on Resource Stewardship are doing. We have one work stream which is theoretical, if you like. It's thinking about the problem of how we understand the way decision networks behave. So one of the problems we have, for example, in the climate issue is we have this model, which I'll come back to in a minute, of a global decision maker. In effect, the idea that we will gather together in some kind of international conference and agree on a consensus policy for climate for the coming decade. and it's basically this unitary decision maker, which I think is part of the problem of actually making progress on climate, because of course that's not the way decisions get made. Decisions emerge from networks of decision makers. They very seldom, except under sort of pretty extreme political systems, get made by a single agent. Certainly decisions at the level and the implications of the climate one. So understanding how decisions emerge from networks is a key aspect of the ONPOS program. And a lot of that work is theoretical, thinking about, and Chris Farmer, who's also here somewhere, is also engaged in the mathematics of how these networks work and how you can try and discern what the network is when you're sort of looking at what decisions get made and how they're affected by inputs and outputs. There's a second work stream we've got, which Steve and Tim Palmer are involved in, with and David Vanilla is actually David Vanilla is involved in several of these work streams, which is understanding decision makers and how they behave. So going out and talking to individuals and working out sort of what the nodes of this decision network, if you like, how those nodes actually function. And in fact, they've already recruited a couple of postdocs whose names I've forgotten, who will be working on that. So this is actually out of date. It's not David Vanilla, but it's
Sophie Haynes.
Sophie Haynes is going to be working with, who may well be here. Hello, Sophie. Welcome to the Oxford Martin Programme on Resource Stewardship. Well, anyway, you see it's a well-prepared lecture. So let me edit this slide slightly. Okay, so just bear with me on that one. And then there's a third work stream looking at resource allocation decisions on a particular area, water and land resource allocation, which Jim Hall, Kathy Willis and Renee Benares are involved. But I'm going to talk about what we sort of christened work stream 0. So I'm for reasons which I'm not entirely clear on, I'm coordinating this enterprise. But I'm left with a sort of small amount of research to sort of push on myself, and the area which I want to focus on under this program is this whole question of how we treat the atmosphere as a global exhaustible resource. And this is really what this lecture is going to be about. So I'm sort of going to now focus on thinking about resource stewardship in the context of climate change and emissions and how we treat the atmosphere in emissions. And I'm going to motivate this because the main thing the Oxford Martin Programme on Resource Stewardship has done so far has been for me and Jason Blackstock to fly to Doha in Qatar to attend the UN Framework Convention on Climate Change conference there. Which is interesting, because there was nothing like going to Doha, this is Doha, by night, to make you think about the ethics of resource stewardship. So it's an extraordinary place. It is built, of course, on fossil fuel wealth. It's the highest per capita income country in the world. It's the highest carbon emissions per capita country in the world. It's also, from this picture, you can see it presents immediately some very fundamental challenges to the kind of things we tend to take for granted in the climate issue. I attended the World Business Council on Sustainable Development meeting there and had an interesting argument with somebody from Philips who was very proud of the impact of Philips low energy light bulbs on emissions. This scene, many of those bulbs you're seeing there are low energy light bulbs, right? But I think it does raise the question of the impact of more efficient technologies on emissions. We tend to, the impact of low energy light bulbs in Doha is just, well, let's use more of them, rather than let's emit less. And that's not unique to Doha either. There's some studies around which suggest that the implications of more efficient use of resources are not always. Nick Gary's here, and we're going to hope sort of maybe have have an argument about that when we get to question time. But don't interrupt yet, please, Nick. Okay. Because that would be a disagreement as opposed to a technical issue. The symbol of Doha for me actually was this orange thing in the foreground, which I saw first by night, and it was this amazing. It changes colour. I should have had a movie, but it's sort of waves of colour go up it as the LEDs change. And then in the morning you go past and you discover it's a multi-storey car park. And it's the kind of, and it's easy to, well, you know, okay, so it's easy for us to sort of, to laugh at that. But then you sort of step back a bit and say, well, we're replacing our kitchen. Confessional mode here, because I'm in a humanities class. You're supposed to know. We're currently replacing our kitchens, and we're spending a whole lot of hassle and a whole lot of money. And just before it started, our 6-year-old asked, "What was wrong with the old kitchen?" And it was a tough question to answer. It wasn't, you know, it worked. So why we got, well, but we think we were fed up with it. We wanted a nicer one. Well, you know, the Qataris were fed up with what they had before, and they wanted a nicer one. So I think there's, you know, it's very easy to look at this and say, well, that sort of conspicuous consumption is wrong. But I think perhaps we can flag this for discussion. You know, is there any sense in which we can sort of sit here in Oxford in the Oxford Martin programme and say this consumption's okay and that consumption is wrong? So part of this talk will be really asking, you know, to what extent can we decouple the whole climate issue from these arguments about good versus bad consumption? Because it's the sort of ethics of consumption that is critical, I think, ultimately critical to the climate issue, and the problem of separating arguments about the ethics of consumption from what we do about climate change is central to actually making any progress on climate at all. Because as long as the argument remains about the ethics of consumption, as long as the argument seems to revolve around telling the Qataris they can't have more skyscrapers, we're not going to make any progress. But I'm going to start off with a much more specific question, which we were talking about in Doha, which is also the subject of an Oxford Martin policy brief that Jason Blackstock and I are working on at the moment, at least we're working on when we find the time to do so, which we are trying to, which is a sort of current hot topic, as it were, in the whole climate change debate, which is prioritising short-lived versus long-lived climate pollutants. And you may think, oh, he's going to get technical at this point here, but it's actually a topic which really brings home some of the ethical issues, or highlights some of the ethical issues involved in the climate debate. So that's one point I want to talk about. And the second one, which we also much discussed in Doha, was what are the implications of the new loss and damage agenda, which has now been placed on the UNFCCC, into the UNFCCC discussions. And the implications of this loss and damage agenda is that we're going to start talking about, at least, not necessarily doing anything about, but talking about what countries that are adversely affected and by unavoidable consequences of climate change, what their entitlements might be. Are they entitled to compensation? And if they are entitled to compensation, from whom does that compensation come? That's a really interesting ethical dimension to the climate question, which is relatively new. And one of the worries I have about a lot of the discussions that I heard going on there is they're essentially ethical discussions disguised as technical discussion. So this whole discussion about short-lived versus long-lived climate pollutants, it's carried on in a very opaque technical language of greenhouse gas metrics and global warming potentials versus global temperature potentials. Don't worry if those words don't mean anything to you. They don't mean anything to most people using them either. And what's, you know, whereas the really important questions are actually ethical ones that are not really out on the table, or at least are sort of being sort of slipped in by the back door. That's worrying, and that's why, you know, one of the reasons I think why the issue is making such slow progress. So let's talk a little bit about these short-lived climate pollutants. You may have heard of them. If you're an outsider of the climate issue, you may have heard of soot and methane as the sort of new in vogue issues, the way we're going to solve climate change. There's a whole new initiative, the Climate and Clean Air Coalition, launched last year with a big push from the Obama administration. There's sort of Hillary Clinton and others launching this initiative. And the aim of this initiative is to make rapid reductions in agents like methane and soot, which affect the climate, and they affect the climate considerably in the short term, and are arguably the fastest way of reducing climate change by attacking these short-lived climate pollutants. So this is an example of a brick kiln somewhere which is clearly gushing soot into the atmosphere at an alarming rate. And it's not only, you know, the other attraction of attraction of these pollutants, or attraction of attacking these pollutants, is that they cause a lot of harm in addition to the warming effect they have on the Earth's climate. So you can motivate people to do something about those kind of emissions, even if, you know, without talking about climate at all. So that's the sort of these co-benefit arguments are used extensively to motivate more focus on short-lived climate pollutants. But what, you know, and sort of this is typical of a lot of the rhetoric about these things. Article in The Economist a couple of weeks ago. If people did everything they could to reduce black carbon emissions, it would strip half a degree temperature out of the process of global warming. Or to put it another way, give politicians 2 extra decades to tackle the less tractable question of what to do about CO2. So if you're a politician, particularly if you're a politician in the US or high emitting, or Qatar for that matter, that's great news. I mean, 20 years is forever. So if, I mean, it's certainly probably beyond, maybe not in Qatar, but in America it would be beyond your term limit. So you don't need to worry particularly about you know, you no longer need to, the implication is you no longer need to worry about CO2. And I mean, Jason is much more, Jason Blackstock, who works with Steve in INSIS, I should say, in the Institute for Science, Innovation and Society, is much more plugged into the policy community than I am. But he says there are plenty of politicians out there who are jumping on this as, yeah, great, we can solve climate change this way, so we don't need to worry about CO2 emissions anymore. And you know, the question is, okay, so where do these numbers come from? So let's just think a little bit about what these agents are and what the difference is between them and carbon dioxide. So these so-called short-lived climate pollutants, methane, black carbon, also tropospheric ozone is another one which also has a substantial short-term impact on climate. They persist in the atmosphere for anywhere between a few days to a decade or so for methane, whereas in contrast, carbon dioxide, once it's released from fossil sources, continues to affect the active climate, the active carbon cycle forever. I mean, in effect, until it's turned back into rock again by natural processes, which you can imagine is a relatively slow process. So you can think of CO2 as an accumulator in the system. If you pump out CO2, the impact accumulates indefinitely. Whereas the short-lived climate pollutants, so for CO2, its impact on climate increases the more you emit overall. Whereas these short-lived climate pollutants, their impact on climate depends on how fast you're emitting them. If you stop emitting them, their impact goes down. If you emit faster, the impact goes back up. It doesn't really matter what you did 20, 30 years ago, because those emissions you made 20 or 30 years ago would have been, as it were, washed out of the system. So we immediately see, this is sort of nicely illustrated in this figure from a very well-known paper by Drew Shindell and co-workers, which came out last year, illustrating the impact of cutting short-lived climate pollutants versus cutting long-lived climate pollutants so you can see here the blue curve is what you get. Notice this only goes out to 2070, which is, I'll come back to in a minute. The blue curve is what you get if you take immediate action on short-lived climate pollutants, but don't do anything about CO2. So you can see you get some mitigation of climate change in the short term, and so let's just focus on that for now. Alternatively, the red curve is what you get if you work as hard as you can on CO2. And one thing you'll notice is that in the short term, working as hard as you can on CO2 makes relatively little difference because CO2 accumulates. Most of the climate change from CO2 that happens over the next few decades is already in the bag. It's already resulting from the CO2 emissions we've made over the past 250 years. So if you want to make a difference to climate change over the next 20, 30 years, attacking methane and soot is the right thing to do. Indeed, if you don't care about climate after 2050, there's relatively little point in doing anything about CO2. I heard a rumour once, I don't know if it's true, maybe somebody else here has more information, that Donald Rumsfeld was firmly convinced that actually we're all going to fly up to heaven in 2050 anyway. And if you believe that, then the Bush administration's policy on climate was actually perfectly rational. Anyway, I don't know if anybody here has more on that, but anyway. So it is about this, how much do we care about generations alive today versus how much we care about generations that would be being affected by climate change beyond 2050 is the real dilemma here. And the difficulty with this problem is that, based on the discussions in the UNFCCC, the hope is that the scientists are somehow going to tell people what to do about it. And so comments such as that quote in The Economist are being passed around as evidence that you can, that was actually, it wasn't clear from the article whether it was a quote from Piers Forster or just the journalist extrapolating from what Piers Forster had said. I suspect it was the latter. But Piers Forster's a well-known climate scientist who was talking to the Economist journalist about the implications of black carbon, and that was where that sort of reducing black carbon could potentially buy you 20 years to think about what to do about CO2. So for the purposes of teasing this out for the Doha meeting, Jason and I sort of looked at a sort of idealised representation of all this. So suppose we've got sort of two extreme scenarios here. One in which CO2 emissions carry on going up until after 2050 and then come down again. And I mean, CO2 emissions will eventually go down because there's a limit to the amount of carbon we actually have underground. But, this would constitute a relatively high emission profile, the red curve there. And the blue curve corresponds to sort of immediate and aggressive CO2 mitigation. So we just sort of pulled these up to give us sort of two extreme contrasting views to sort of tease out what the impact of long-lived versus short-lived climate mitigation of long-lived versus short-lived climate agents was. And if we sort of attack this, if we attack these short-lived pollutants immediately over the next 30 years, then we can push these CO2-induced warming curves down by half a degree, okay, over that period. So you can see that, that pushes the blue curve down indefinitely, or alternatively, it sort of delays the warming from the red curve. Okay, so that's where that sort of 20 years figure comes from. You're sort of delaying warming by roughly 20 years. Or if you are reducing CO2 aggressively, you're actually having some impact on the peak warming. But what's the argument for doing this now, acting immediately on these short-lived climate pollutants, which is the sort of big debate we have at the moment. So expect in the build-up to 2015, where we're supposed to sort of agree the next sort of major set of targets for climate, expect a lot of discussion of this issue, because a lot of people are very keen that in 2015 we get serious commitments on short-lived climate pollutants and a sort of general dither on CO2. And you can see why, because apart from anything else, all the action on short-lived climate pollutants will be done in places like India, southern China and so on, who are understandably a little bit grumpy about the fact that suddenly they're the ones who are sort of put in the front line on the climate issue. But you can see how, those countries that do not emit very much methane and black carbon, but emit a lot of CO2, Britain, for example, would potentially do very well out of a refocusing of climate policy on these short-lived agents. So, watch this space carefully. So the argument is, we've got to act on these things now because they have an immediate benefit. On the other hand, if you ask yourself, well, what happens if we don't act on them now? So what happens if we do the same thing, but we just do it in 30 years' time? What does that do to the projected climate change? And here, again, in a very idealised, this very idealised setting, you can see, so the dotted lines here are what you get if you just defer for 20 years. Okay? And you can see that, you know, on the high-end emission scenario, over the next 50 years, you end up with more warming, but the where you end up is essentially identical. It doesn't make any difference whether you cut now or cut later, you're going to end up in the same place. For the low emission scenario, the really aggressive one, where you're working on CO2 mitigation very hard, you perhaps see a slight reduction in peak warming, maybe a couple of tenths of a degree. I mean, it's kind of marginal whether that's significant, whether, you know, in the end, if you're here in 2150, having followed this path or this one, okay, would species or the ice caps be any different? I mean, it's kind of hard to tell. I mean, this one, because in reality, of course, we have, you know, climate noise wobbling around these curves. It's very easy to draw these things with a simple climate model, but, you know, the reality is it's going to be bumping around anyway. As indeed we've seen over the past decade, you know, we've got a sort of wobble going on in temperatures at the moment. So it might actually not make that perceptible a difference, which path we were to follow. And therefore the case for immediate action on short-lived climate pollutants is much less clear. In fact, we can sort of try and quantify this by saying, look, you know, what happens if we make early and aggressive, if we assume early and aggressive CO2 mitigation, then it makes a little bit of a difference whether we cut these short-lived climate pollutants now or if we cut them later. Okay? If we don't make this early and aggressive CO2 mitigation, it makes absolutely no difference at all to where we end up. So this is interesting because it means that the case for short-lived climate pollutants, the case for taking early action on short-lived climate pollutants is actually predicated on the assumption that we're going to reduce CO2. So if you frame it that way, it seems rather odd that it's been suggested as an alternative to reducing CO2, because it only makes sense if you do reduce CO2. So, and this is illustrated even more clearly in this figure, which is from a paper, Neil Bowen's a PhD, so just finished his PhD thesis here. He hasn't had his exam yet, so we may have to withdraw this figure, but hopefully his examiner's passing. So this just illustrates the relationship between the impact of these short-lived climate pollutant measures on peak warming as a function of how fast CO2 emissions are changing at the time the measures are implemented. And the point is, if CO2 is being reduced rapidly, that's sort of this region here, so if you're in a scenario where CO2 is going down fast, it's possible that reducing short-lived climate pollutants will actually make a difference to peak warming. But if you're in a scenario where CO2 emissions are going up, which is the scenario we're in case you hadn't noticed, then there's no dots in this quadrant. There's no circumstances under which cuts in these short-lived climate pollutants will make any difference to peak warming under circumstances that CO2 emissions are going up. Yes?
What are the colour of the...
What are the colours of the dots? They're different scenarios of the future emissions. They're different assumptions about global economic development and equity and that sort of thing. And they're not exhaustive. There might be, but the sort of picture, but they're meant to sort of span the sort of general range of uncertainty. And the main point of this is, you know, there are no dots up here, and it's almost impossible to conceive of a scenario in which there would be a dot up here, because in effect, unless you're reducing CO2 very rapidly, cutting these short-lived climate pollutants can't have any impact on peak warming, because by the time temperatures peak, the impact of cuts in these pollutants will have completely dissipated out of the system.
What's up with the lack of error bars? Like, what kind of error margins do we have?
That's a really good question. So I've got some error bars on the next plot, if you want some error bars. And in fact, yeah, producing a version of this plot with error bars would be helpful. I'm not sure it would, I'm
just asking if it crosses over into that quadrant at all.
I hesitate to say no, it wouldn't, because I haven't actually produced that plot. But I'm pretty confident it wouldn't, because as I emphasised, the reason that quadrant is kind of excluded is a pretty fundamental one. It really doesn't matter what you've got wrong about the properties of these gases. The only thing that this really depends on is the fact that CO2 accumulates and these other gases don't. So the only thing that could move one of these things across into that quadrant would be that if we got the fundamental properties of CO2 wrong, in that CO2 sort of turns out not to accumulate after all, and that's pretty solid. So there's not a lot of error on that assumption. So I don't think including error bars on this would change the basic message of the sort of lack of dots in the top left quadrant, because it emerges from a very simple property of the system rather than. But it's a good question, and I don't know, maybe Neil's examiners will require him to put error bars on this, and he can get back to you. But so each of these, you know, each of these trajectories has some uncertainty around it, but that doesn't. But the impact of short-lived climate pollutants is folded on to that uncertainty. So the point is, if it so happens the system is a sort of higher response than I expect, then the short-lived climate pollutants will bring me down from that, but they will still have the same kind of impact. Yeah, and so I think it wouldn't change the overall picture, but it's a good question. So to get on sort of why this matters, why it works like this, is that CO2, as I've sort of stressed several times in this talk, matters in the long term because CO2 emissions accumulate, unlike these short-lived climate pollutants. So this is illustrated by this plot, 3 idealized profiles for emissions, one in which they carry on and then come down very fast, one in which they sort of start going down relatively soon, and then the green one in which they start going down almost immediately. And the integrals under these 3 curves are the same, so the yellow areas above and below the blue curve are identical. So that area there is the same as that one, so the total amount of carbon you've injected into the atmosphere by 2150 is the same under all 3 scenarios, and the temperature you end up at is the same. So this is just emphasizing the point that it doesn't really matter when you emit CO2 into the atmosphere, what matters is how it accumulates. But this presents us with this ethical dilemma. If we, immediate cuts in short-lived climate pollutants are very unlikely to have any impact on peak warming unless CO2 emissions are falling at the same time. So if you're prepared to believe that we are going to cut CO2 emissions dramatically over the next 20 years, then it does make sense to focus on short-lived climate pollutants as a way of reducing peak warming. But of course, but if you don't believe that, and the evidence is against that at the moment, then the cuts in short-lived climate pollutants have relatively little impact on peak warming. But, and this is the sort of ethical dilemma here, it does make a difference to warming to 2050. So reducing methane and black carbon would have a very substantial impact on climate, a much bigger impact on climate than working as hard as you can on CO2 over the lifetime of most people alive today. So, and that's not that's reasonably uncontentious science. So the issue here is not particularly the science of these things, but how we weight benefits in the next couple of decades against the long-term benefit the long-term benefit of avoiding higher levels of peak warming. So that's an ethical issue. I think that's not an issue that we can really we can do our best to clarify the science, but it's not one we can actually resolve. It is, however, worth thinking as scientists, how we can communicate this issue better, because I think statements like cuts in short-lived climate pollutants could buy us 20 years for CO2 are potentially very misleading. So this is really one of the things I want to sort of talk about. This is sort of the only new bit of work actually that I'm presenting in this talk is how we can compare the impact of short-lived climate pollutants honestly to people in a way that doesn't get lost in the technical jargon of greenhouse gas metrics and so forth. So to do this, we need to ask ourselves, how fast are CO2 emissions, current CO2 emissions, increasing our committed peak warming? Okay? Because if it's true that half a degree is worth a 20-year delay in CO2 mitigation, that implies that if we do nothing, I mean, to my mind, a reasonable interpretation of that statement is if we do nothing about CO2, then our committed peak temperatures would go up by half a degree if we waited 20 years. That sort of seems to me to be a logical implication of that economist's claim. Now, do you remember that the quote in The Economist said, 20 more years to think about CO2 implies that therefore, if you manage to take some measure which knocks half a degree off global temperature, I suppose Steve comes up with a geoengineering, I like to blame Steve for geoengineering because he's in charge of the Oxford geoengineering programme, although it's important to stress the Oxford geoengineering programme is looking at the ethics of geoengineering, not doing it. Anyway, but the point is, suppose we had some geoengineering scenario which allowed us to shave half a degree off global temperatures. What's that worth in terms of CO2 emissions? And I think that's a good question. Can we sort of quantify that a bit? So we have a simple relationship coming out of the science of the carbon cycle. Roughly speaking, over the whole Anthropocene, 1 trillion tonnes of carbon injected into the atmosphere gives you about 2 degrees of warming. And 2 trillion tonnes gives you about 4 degrees, and so on. It's a pretty simple relationship. Okay, so total amount of carbon you inject translates into the kind of warming you should expect. So current emissions, roughly 10 billion tonnes of carbon per year, 100 billion tonnes of carbon per decade. It's not a complicated sum to work out. That implies 0.2 degrees per decade. So that sort of implies that if you had something else which cuts temperatures by half a degree, that's 25 years. Okay? Sounds like The Economist was right all along. Okay? But then wait a minute. What does that imply? So in effect, what you're talking about here is you've got emissions doing this, and you're asking where would temperatures peak if this is now? You're asking where would temperatures peak if emissions did that? Okay, so this is 0. Okay, versus carrying on for 20 years and doing that. Okay, that's what that comparison, 10 billion tonnes of carbon per year is equal to 0.2 degrees per decade. That's what that comparison implies. Okay, now nobody, I hope, envisages emissions doing this. Okay, that would be the only kind of scenario that would result in emissions doing that would be really unpleasant. Okay, so that's, it's not a scenario we're actually considering, and yet it's actually the scenario underlying that kind of equation of emissions to committed warming. So what's a more realistic way of thinking about this? Well, start from the fact that cumulative CO2 emissions determine peak warming, and that implies if we're committed to reducing to limiting peak warming to 2 degrees, for example, which we are. I mean, that's what the world's governments are notionally aiming for. That implies, in order to keep the total below 1 trillion tonnes, remember it's roughly 1 trillion tonnes per 2 degrees, okay, in order to keep the total below 1 trillion tonnes, emissions need to decline, on average, from now on, by roughly 2.5% per year. Okay? Just to illustrate that, that's the sort of green curve here, okay? They're wobbling around like that. If we start now, okay, emissions would, they might overshoot, but the area under the curve has to be the green area here to give you a 2 degree committed warming, okay? And so now if you think about what's the impact of delay. Well, obviously, you could delay, and as in that other figure I showed you, let's go back to it, here we are. You could delay by 20 years and cut much faster, 10% per year, and actually have no impact on peak warming. But ethically speaking, that doesn't make very much sense. You're basically saying, well, we're going to do nothing now, but the citizens of the planet of 2040 are going to somehow cut CO2 emissions by 10% per year, which nobody actually has any idea how they would actually do that. So, you know, ethically speaking, that you might say that was questionable as a way of framing the problem. So, a more realistic way of thinking about it is say, look, we're sort of notionally committed to 2 degrees. That implies a 2.5% per year reduction. If we delay, just to keep one thing changing, let's just think about what's the impact of delay. But keeping the rate of reduction after the peak the same. That's a more realistic way of thinking about the impact of delay. And you find now, because of course it's the area that matters, the additional area in this yellow band here is very different from the additional area if I just chop the 2 off. See what I mean? Yeah? And you find that delaying by 11 years or so knocks up global temperatures by 0.4 degrees. So instead of 25 years, so instead of half a degree being worth 25 years on this sort of absurd scenario, it's worth only 12, 13 years on this sort of way of thinking about the problem. I haven't seen this anywhere, but I think it's interesting. It's a good way of thinking about it, because it sort of tells you, yeah, it's not worth nothing, but as Nick says, 10 years is now on CO2 policy. You know, it takes us 10 years to do anything, even convene a conference. So you know, that sort of kind of puts the potential of these short-lived climate pollutants into perspective. And of course, the other implication of this way of thinking about it is if you don't meet the 2-degree goal, if you sort of say, well, actually, we'll probably end up at 3 degrees, then, okay, this is what happens. Then basically that says, on average, you're going to reduce slower in the future. Okay? So this is the rate of reduction you would get if you're going to end up with an area under the curve consistent with 3 degrees. Okay? And then, of course, you know, the extra area goes up very rapidly. So then suddenly, you know, cutting short-lived climate pollutants only buys you 8 years or so. Or if you think you're going to go to 4 degrees, your colour scale runs out. Sorry, I was producing these plots this morning. But I don't care. If the colour scale runs out at 6 degrees, that's kind of realistic. I think we don't know what we'll do beyond 6 degrees. So here's a nice way of framing this problem of comparing cumulative emissions like CO2 with the impact of these short-lived pollutants. All I'm really doing here is saying, you know, thinking about the areas under these curves, we can equate committed CO2-induced warming, or the rate of how fast committed CO2-induced warming is going up, by just saying, right, the current CO2-induced warming rate is whatever it is, 0.15 to 0.2 degrees per decade. Multiply that by the expected peak warming, and divide by the current warming, because basically, if you think that things are going to peak at 2 degrees, and that's roughly double where we're at now, if you delay, the commitment goes up in proportion to that, in proportion to the amount. I haven't really thought out how to say this, but hopefully you're getting it if I wave my hands enough. The commitment's going up by the amount by which the committed warming is greater than the current observed warming. Okay? We can come back to that at question time, if it made no sense to you. And the point is this, basically, the committed warming is going up twice as fast as the observed warming, is the bottom line. If you think we're going for 2 degrees, because the current warming is about 1 degree, so the committed warming is going up at roughly 0.4 degrees per decade, even though the actual warming is going up at 0.2 degrees per decade. Okay? So it's a very simple way of thinking about it, and I think it's actually a much more realistic way of comparing these gases than this sort of cataclysmic scenario that nobody actually thinks is going to happen, or nobody hopes is going to happen. I, as usual, have got about a third of the way through the lecture. So I'm going to cut to, so just excuse me for a minute while I just do some rapid editing. And, oops, oh no, I didn't want to do that because that was fun. Okay. So sort of come to instead of sort of thinking about and sort of to get things going for the questions, thinking about what we're actually going to to do about CO2. So I sort of argued that this whole sort of excitement about alternatives to CO2 is misplaced. They buy you a certain amount of time. It's not completely misplaced, but they don't buy you very much. In fact, the amount of time they buy you is kind of inside the noise as to what impact measures we might take to reduce CO2 actually have. So, you know, it all comes back to CO2 policy. And the problem we have with CO2 policy is that we conceive of it in this way. And this is where going to Doha would be really helpful for anybody who sort of is thinking about the climate issue. You've got to look at the scene in Doha and ask yourself if current policy can possibly work. The main sort of the scenario we have for climate policy is that we will somehow raise expenditure on emission taxes and permits, and somehow turn the entire global energy economy upside down. Okay, from a almost exclusively fossil fuel-based economy to one which is completely different, and thereby make all these near-term impacts of climate change go away. Of course, that's not what's going to happen. It's not what's happening. And the challenge we face is it's going to be very difficult to motivate that happening when the amount we spend on energy, and this is a sort of number that people need to sort of take away with them, the amount we spend on energy dwarfs estimates of the near-term impacts of climate change, certainly over the next 50 years. So the amount we're currently spending on energy is over $5 trillion per year, and most of that's fossil energy. Okay, so that's roughly $1 in every 10 that's spent. It's extraordinary numbers. That's why Doha is the way it is. Okay. Now, estimates of what the near-term impact of climate change are vary wildly. They're very uncertain. But the sort of numbers that are kicked around are in the hundreds of billions of dollars per year, not the multi-trillion dollars per year. So, you know, it's the order of 10% or less of the amount we spend on energy. Okay? And so to solve a problem this size, we're proposing to completely upend an industry that's this size. Okay? And that's the problem we have. So, you know, I think we're not going to make progress on this until we work out how we can kind of incorporate these long-term impacts of climate change into the cost of energy as we use it at the moment. And I think this plays directly to the loss and damage agenda, which has now come onto the UNFCCC negotiations, why I think that's it was not a particularly heavily reported on development, but I think it is actually ultimately one which is going to matter a great deal. And the reason I think it matters, I'll just sort of again give you something to think about, and bear with me as I flick over the jokes. Moving on. This is where it freezes because it's a very slow slide. Okay. And so just to sort of wrap up, you know, we've got this current situation, and the sort of ethical challenge we face is producers of fossil carbon, if they inadvertently release it into the bottom of the Gulf of Mexico, they are responsible for cleanup. Okay, so this is the notorious BP disaster a few years ago, and you know, this shrimp fisherman may have lost a lot of money as a result of the contamination of the waters of the Gulf of Mexico, but he was at least able to get a job while he wasn't shrimp fishing, helping BP with the cleanup, and also he was entitled to a substantial amount of compensation from BP as a result. On the other hand, if you release fossil carbon into the atmosphere, okay, and thereby make events like some of the wildfires and heat waves that have recently been sweeping Australia. I was in Tasmania a few weeks ago. It was kind of ironic. We had this meeting with climate scientists there just after they had to invent a new colour for the Australian weather maps. And Tony Abbott still said it's nothing to do with climate change. Or for that matter, storms threatening the Arctic village of Kivalina. That's not your problem. The problem is entirely the problem of the victims of these impacts rather than the problem of the polluter. And that's, I think, really the ethical dilemma we face and want to sort of think about is how we can connect up those things such that the extraordinary wealth that can be generated by burning fossil fuels can somehow be connected up with addressing the problems that they cause. And I think that'd be a good point to move to questions and discussion.
Okay.
Thank you.